Hello. Welcome to the recorded version of the Ride Control Masterclass for the upcoming Pep Boys campaign. The purpose of this recorded presentation is for internal use only for our technical product specialists around the country as a reference point for all this content that we have that we're going to get into today. The session is going to last approximately 2 hours, which is the allotted time that we have with Pep Boys for each of our daily 9 a.m. and 1 p.m. sessions when doing this campaign. As I'm doing this recorded as a voiceover, I do have a laser pointer on the screen. I will park that in the bottom right-hand corner, and when needed to point things out on slides, I will show that as needed. As you can tell, this presentation is designed to be informal as far as the recording, and when you teach the class, hopefully you won't sound as digital or as serious as I am right now, because we want the class to be fun and engaging and get the advisors and the technicians for Pep Boys engaged in recommending ride control replacement, being aware of our other product lines we have, such as Moog and Wagner, and Walker exhaust. Which brings me to the purposes of why we're doing this with Pep Boys. As I see it, there are 3 main focuses. One is, and the largest focus that they've asked for, is the replacement of Monroe shocks and struts. It is one of the most undersold categories on vehicles. It is also one of the most difficult categories to sell. So we will focus heavily on that. The second purpose of the training is to make sure that Pep Boys is aware of our great product lines that we have, which is Moog and Wagner, and we will cover those later. And then finally, at the tail end of the presentation, we spend a little bit of time talking about Walker exhaust. Walker exhaust is one of those lines that is very undersold at many locations because they, A, do not realize they have the capability, or B, they do not have the availability of parts, or C, they are just afraid to sell it, right? So we want to make sure that they are aware of it, and you will find as you teach these classes that many of them are amazed that they have this product line even available to them. So as I get ready to start the recording, I thought about the best way to do this is to just go into masterclass as though you were all a room full of advisors and technicians from Pep Boys. So I will now start the class. And as always, you can ask questions as we go. And so we'll get this recorded, and I hope you can find this as a good reference point. As you can tell, it's going to be very informal, so just bear with me with any misspeaking that I do, and I'll try to correct myself on the fly. Okay? So I would like to welcome you all to today's session. I know that many of you are advisors in here and technicians. We have a nice mix. And I will just ask you for today's main focus, which is the Monroe shocks and struts. Show of hands, how many of you would agree that ride control is one of the toughest categories to sell? Go ahead and just raise your hand. All right. So I see a lot of advisors have their hand in the air. We all know it's a very expensive prospect for a customer to grasp, right? They maybe come in for a $50 oil change, and now you are quoting them, $800, $1,000, $1,200 worth of ride control. We're going to help you with that and how to approach the customer and be more productive in recommending replacement of ride control. The other thing that we're excited to share with you today is our other product lines that we have available, which are Moog and Wagner. And at the end, we're going to talk about some Walker exhaust. Show of hands, how many of you in here are currently doing exhaust repair in your shops? Not too many. And if I were to ask you, I bet many of you don't realize that you have this available to you, right? We have the products available. If you don't have it in stock, you can usually get it from your local warehouse, and it can be acquired in other channels as well. So we want to make sure you're aware of that, and we'll spend a little bit of time with that at the end. But before we get into that, let's just start off with the beginning of the presentation here. So the first thing I want to talk about is we're really excited that we have around-the-wheel solutions available to you now. Not only do we have the Monroe product line, which has been around for over 100 years now, and we have a full line of shocks and struts. I'm going to cover some other products that are available, but we now have the Wagner, brake rotors, fluid pads. I have some separate material on that. And with Moog, we have that full product line available as well. So when you look into the wheel well of a vehicle, we have everything from top to bottom, side to side available to you. When you see these brands pop up here on the screen, and you'll notice it's almost everything that's rolling down the road, these are all the brands that our OE side of our business, which is our Tenneco brand currently, has available out there in the market. Tenneco is the world's largest supplier of OE ride control. Therefore, if you're taking ride control off of a vehicle, there's a pretty good chance, if it's the OE ride control, that it was made by us anyways. So we like to say at Monroe, OE is in our name. But there's one crucial thing I like to point out. When you think about OE ride control, if I were to go out tomorrow and buy a brand new Chevy truck and the warranty was 3 year, 36,000 miles, I would ask you, no matter what OE or brand or make or model of vehicle that you're buying, what is the warranty on the ride control? And if you understand how this works, most OEs will only offer at the maximum the bumper to bumper warranty, which would be the 3 year 36 or whatever they're offering. Some of them only say 12-12, right? 1 year or 12,000 miles, and it can be anywhere in between. The key point is that it's not warranted for life. However, our Monroe premium product is a lifetime warranty product, and I want to say limited lifetime. Limited meaning they have to be the original purchaser of the product, and number two is they have to have the receipt. As long as they are the original purchaser, their name is on the receipt, and they have the receipt with our product numbers on there, you can warranty that material. All right, it is a lifetime warranty. That is not only for leakage or maybe a weld cracking or something like that. That is also if they just wear a pair of them out or all four corners out. So for example, if you had a pickup that you put reflexes on and it was 8 years later and they had 100,000 miles on them and you test drive it as a technician, you go, hey, these are worn out. And the customer says, I have my receipt, I had them put on 10 years ago. You can warranty those units, no questions asked. The customer simply has to pay the labor. Again, we do not do labor claims on lifetime warranty. Okay, so that's just a great feature of our warranty for our Monroe product line. So you can see we got an extensive offering. I'm not going to cover all of these, but I just want to point out a couple key things on here. Number one is these complete assemblies, or as we call it, our quick strut or our Roadmatic. We'll talk about Roadmatic a little bit later. But for terminology, complete assemblies, or I'll say quick strut today, these are great. One thing you're going to hear come out of my mouth a lot today is the word spring. When I'm talking about springs and how they degrade and lose ride height, I'm mainly focused on strut technology. All right. Torsion bars and leaf springs tend to hold up very well. They do not tend to weaken or sag as quickly as these coiled up springs that we see on the McPherson type strut assemblies. So when we talk about that today, you're going to hear me talk a lot about springs. This is what we're all used to. I've been wrenching for quite a few years now. I grew up using bear struts in front of the strut compressor, or as I like to call it, the cage of death. And the thing that I don't like about bear struts is most people, when they put bear struts on, they do not replace the spring. All right, and the spring is the backbone of the system. If you think about it, the springs never get a chance to have a break on the vehicle. They are always holding that corner of the vehicle up in the air. We're going to cover some of these other products on here today, but load adjust, these will carry up to 1,200 pounds additional weight depending on the application. So these are great for the back of like pickups and vans. We're going to talk about Rancho at the tail end of the presentation on ride control. We got max lifts. These are great for those rear lift gates on vehicles. If somebody's using like a hockey stick or a broken piece of broom handle to hold their rear lift gate up, we do have the max lift available. And conversion kits. Just touching on these very quickly. So a lot of people that are driving like Lincoln Navigators, Lincoln Town Cars, Cadillac STSs, they have that factory adjustable suspension system in the rear. You see them coming into your shop with rear bumper dragging on the ground. They have probably not gotten it fixed because when they went to the dealer or a repair shop, they probably got quoted anywhere from maybe $900 to almost $3,000 is kind of the range of quotes that I've seen. It's not affordable to do that for them. These kits right here retails for somewhere approximately in the $350 range, give or take, and plus labor to put them on. And you can get the back end of that vehicle back up in the air again, and now we have a safely operating vehicle. So today you see in front of you, you have a conversation guide. This is a map approved document, and we're going to go through the 4-step process on here in detail. And then on the back side of it, if you flip it over, you will notice there's what I call the scorecard, which develops a score for the vehicle's steering, suspension, even a little bit of braking on there. So it's just a deeper dive than the normal complete vehicle inspection. And we're going to use this today. But before we get into that, let's start out with what we call ride control vehicle dynamics. When we talk about vehicle dynamics, what we're talking about here is how does this vehicle go around the corner without running off into the guardrail? That's because there's a lot of systems working together in harmony, which would be our braking, our powertrain, our steering, our suspension. All of those systems have to work correctly together to give us a safe corner around this vehicle, around this curve. So you think you might have rough roads in your state, but this was filmed in Michigan, and I am a proud Michigander, and we are proud of our potholes, right, and our rough buckled roads. And it always happens in the spring when the frost comes out of the ground. So when we talk about ride control, we are taking care of those vertical body motions, right? We are trying to, and although it has a huge effect on comfort, the key part of ride control is safety. It keeps the wheel in contact with the ground, which we will cover in the upcoming slides. The other thing it does for us is it helps to dampen NVH, or noise, vibration, and harshness. And what this are is those sharp little jolts that you feel going over bumps or road texture, the little expansion joints in the roadway. And this has gotten worse over the years trying to control this, because think of what has happened to the ride height of, or the sidewall height of our tires in the last 15 years. We used to have these really nice tall sidewalls, which kind of worked like a rubber shock absorber, right? We had our tire kind of deflecting, but now we have these very short sidewall heights with these low profile tires, and it can definitely generate some huge NVH that we have to try to counter with our ride control. So it's important that our ride control is in good condition. So if you put tires on, you know they've got to be on the road, right? We don't want an overloaded contact patch. We don't want too much weight on the tire. We don't want it to be airborne. You can see the vehicle in the background catching some air there going over the bumps. That's not safe. That's not good for control and handling. We want to have that tire go over the bump, and the ride control system push that tire right back down to the ground and keep it on the ground the entire time. And this is a pretty good visual here, so it's a little bit small for those of you in the back, but what I want to point out is the vehicle on the left is what we've got going around the corner when we've got healthy ride control. So this is either new ride control or a new vehicle or a new used vehicle. It's got low miles on it. And so if you think about somebody taking a route to work every day, say your customer drives a certain route and they go around a certain curve, when their vehicle has less miles on it or new ride control, healthy ride control, they might take that corner every day at 40 miles an hour without even thinking about it. And now if you look at the vehicle on the right, what happens is over time, and you hit that 5, 6, 7, 8 year mark, right? And even though they might have new tires on there and new brakes, if it's the original ride control, what we will start to see is the tire deflecting or lifting or getting a light contact patch going around this corner. And so now years later, they're taking that same curve on that same route to work at maybe 30 or 35 miles an hour. And the reason they've lost that speed is they cannot carry that speed through the corner because of they're losing their contact patch and their control in the corner. All right, we put new ride control on it, and look, lo and behold, we have the performance that we have on the left. We keep that contact patch down with the ground. This is a great thing to point out to your customers, that ride control has a huge effect on keeping the tire contact patch on the ground for cornering, stopping, and accelerating. When we talk about braking, this is one of the things that a lot of technicians will miss, myself included. So we want to think about this. If you've got a customer coming in for frequent front pad replacement, what we want to talk about is weight transfer. So a lot of people don't realize, but we actually like to slow down the extension of ride control units. What that does is it counteracts the natural tendency of the spring to want to expand. And so therefore we keep the weight of the vehicle down on the rear tires during braking. But instead what happens is once vehicles get higher mileage on them, and that can typically be 100,000 miles or more, could start at 80,000, anywhere in that range, depending on the use of the vehicle and the class of the vehicle. But as all vehicles wear out, what happens is when you hit the brakes, instead of this back end staying down on the ground and keeping these rear tires in contact with the road and doing their braking, and the braking system in the rear doing their braking, we throw that weight to the front and we start making the front brakes do all of the work. And therefore we go through frequent front pad replacement. This is another good visual right here on the right. During normal braking, we should have kind of an equal split from front to back, right? Where we're not overloading the front tires, but what ends up happening with weight transfer is we get these overload on the front tires and we get extended stopping distances. To the point that I say, why should a consumer purchase ride control? The new shocks and struts make your vehicle safer. The brakes help you stop, but the shocks and struts actually help you stop sooner. This is a very realistic demonstration of what happens is when we get vehicles that have worn out ride control, you can see right here on this Acadia, the rear end popping up in the air, and you can notice that we've demonstrated there's going to be a longer stopping distance. When we put new units on the vehicle, we actually shorten the stopping distance by keeping that weight on the rear tires. And on some vehicles, I have seen it be as much as 10 feet per worn out unit that gets replaced. So if you think of a stop from 60 miles an hour down to 0, after putting on ride control, I've seen a lot of vehicles from a stop from 60 miles an hour down to 0 shorten up as much as 20 feet, right? Which is huge. If you think about you on your drive home, or you're driving down the highway and a deer runs out in front of you, or there's a traffic jam, Sometimes you're within a foot or less of that vehicle in front of you, right? Or there are accidents that happen. Think of how much safer it would be for your customer if they had that right pedal feel and pedal control and stopping availability to them. So tires tell the story, do they not? And so we see all these different wear patterns. And the key thing I want to drive home with this slide is, and this is very important, is that tires tell the story. And if you're putting new rubber on somebody's vehicle, if you're putting new tires on, whether it's one or two, but especially if you're doing 2 or 4 and doing them in pairs, and you see any of these tire wear patterns, we need to talk to the customer about what's going on. So you tell me what causes center wear. Yep, overinflation. And shoulder wear? That's correct, just the opposite, underinflation. And then we've got camber wear and toe wear. These are obviously alignment issues. High-speed feathering we'll see on vehicles like Camaros, Mustangs, even some Chrysler products can get going fast enough to high-speed feather. And so we want to look for these patterns, right? And this is normally on more performance vehicles during high-speed cornering, all right? The focus of today's class is cupping. And so when we talk about what we're seeing with cupping, some people say, oh, this is lack of rotation, which is actually a little bit more of a sawtooth feel to it. With cupping, we're actually getting a little scooping, or I call it scalloping of the tire. So you feel this kind of a deep lump, and then a high spot, and then a deep area, and then a high spot, right? Consistently even around the tire. This is cupping, typically caused by something worn out in the suspension system. And let's be honest, it's usually worn out shocks or struts on a higher mileage vehicle. You might see some brake skid or flat spot, where this is usually where somebody really locked the vehicle up at a high speed and fully engaged the brakes and got it to lock up, or they left the parking brake on unknowingly, or had a rear brake hanging up or something. But be on the lookout for that. The whole key point with this slide, and this is very important, if you are going to recommend to Mr. Smith or Mrs. Jones that they're going to get 2 tires and 4 tires, and they're going to buy the alignment to correct maybe this issue, right? Or cupping, if they've got this, you got to address the root cause. Because if we put 4 tires on their vehicle or 2 tires on their vehicle, and they come back at 10,000 miles and they have any of these wear patterns, if we did not indicate that on the repair order and recommend to them that they do what they need to reduce inflation to the proper level or increase inflation to the proper level, or if they didn't want to buy the alignment, none of these conditions by any tire manufacturer are going to be a warrantable condition. So this is a very important thing to share this tire wear information with your customer. I encourage you, if you see any of these patterns, to take the tires, get them off, and roll one of those tires up to the waiting area, or have them come to the shop door and have them feel or see this tire wear pattern. And the good selling point is to tell them, protect your investment. You just spent $800 or $1,200 or $1,500 on tires. Let's not have the same pattern happen again when you leave here, because we're not taking care of the root cause of the issue. I hope this really makes sense. And this is really a great selling point on why to get the alignment or proper tire inflation or the worn out ride control in the case of cupping. All right, so let's move on. So alignment, everybody here is pretty familiar with alignment. I'm not going to spend a lot of time on this. Sorry, there's a little audio over here, but the key thing is the top of the tire tipping out is positive, top of the tire tipping in is negative, all right? And of course, we've also got toe, but these are crucial alignment angles that could tire wear. And so the thing with camber, we usually see, and we'll talk about ride height here in just a minute, but we see changes in camber as ride height comes down in the vehicle. And so we've also got toe that we got to look at. One of the key things I like to talk about when you're talking to somebody about camber, I don't talk to customers in those terms of negative camber and positive camber. If I've got the alignment machine readout, I will point out to them, hey, we did alignment, and then I will put my hands up in front of them, right, with my arms and bent at the elbow. And I will say, Mr. Smith, Mrs. Jones, when you came in, your tires were like this, and I'll tip my hands together showing negative camber. I'll say, we did the new tires, the alignment, and now your tires are straight up and down like they should be. And I will move my hands straight up and down. Customers understand that. Even if they're not mechanical, they understand the tip of the tire in and out. Using my arms as motion in front of them, I will show them what that is. And then when I go to cover toe, I will use my feet, and I will show them toe in and toe out and what we did to correct that for their vehicle. All right? So now we get to one of the things that are missed the most out there, and by myself included, ride height. Ride height is one of the largest overlooked thing by technicians. I can tell you as myself, I overlook it. But on most vehicles, we're going to see negative camber develop over time as the ride height of the vehicle comes down. There's a few oddball vehicles out there that produce positive camber, but for the most part, I'd say 98% of the vehicles out there produce negative camber. Now, if you look at this cutaway shock that I have in my hands up here, you can see that I've got this located where the piston is about halfway through the travel, okay? On the OE side of the business, when we set ride height with the OE, we like to have this piston about halfway through the travel on this shock absorber or the strut, right? And so in this case, we're really focused on struts. And so what happens is, as the spring wears out on the strut, we lose by year 5 to 8. I've seen a lot of vehicles lose 3/4 of an inch, maybe an inch. So I'm moving this down right now to show you we're losing about 25% of our downward travel for a compression. Now, what actually happens is a customer, when they buy a new vehicle or a new used vehicle with lower miles on it, they get ready to pull into the McDonald's restaurant and they're hitting that inclined driveway at 8 to 10 miles an hour. And what happens is when their vehicle's new, it doesn't bottom out. But by year 3, 4, 5, they're starting to hear this little thumping noise, but they don't really think anything about it because it's so gradual. And as you get more and more mileage on it, that thumping becomes harder, right? That is the strut bottoming out, right? Or if they do have, leaf springs or torsion bars worn out, that is the shocks bottoming out or the suspension bottoming out. We want to, especially in the case of struts, put new struts in, quick struts with springs, get the ride height of that vehicle back up. We gain back that loss in ride height, which also gives us that room back in our compression. And there will be a noticeable difference that they are not bottoming out the vehicle as often anymore. So that was dynamics. And so we're moving through this pretty quickly. So let's keep right on moving into fundamentals. With fundamentals, I'll ask you, what do shocks actually do? Or in other words, what set of components in the vehicle are the shocks trying to control? The answer is spring oscillation. Notice the vehicle on the left, how nice and steady it is going over the bump. That's a vehicle with healthy damper. The vehicle on the right, or in this case now the top, that's worn out ride control. Notice the extra oscillations. When you have a healthy hydraulic damper on a vehicle, whether it's a shock or a strut, it will actually allow the suspension to compress or extend, right? But as it comes back to what I call the point of equilibrium, or where the vehicle would be setting level, going, in a static position in the driveway or going down the road, it will not overshoot that position. Okay, so what you can see right here is the vehicle on the right overshooting both up and down here and giving us that head bounce, right? The other thing it does is during stopping, it controls weight transfer. This is a very aggressive stop by the sport vehicle here. You'll notice the nose goes down, and yes, the tail does pop up, but it's a very aggressive stop. But notice the body action. Notice how it comes back to a nice, smooth, level position. That is healthy ride control. If we had a vehicle with worn out ride control, right here we would see extra bounces, right? So we would see those extra oscillations up and down. That's what we're looking for when we test drive vehicles. And the other thing it helps us with is improved handling. So as our healthy ride control keeps our steering and suspension more in the position that it should be in, we hold better alignment angles, we hold better contact patches to the ground to avoid that road debris, right? Those dead deer carcasses, those potholes, those cones, construction material. We all know there's all that different debris. And one of the biggest ones that I've learned is semi-tire casings. How many times in a given week do you see somebody hit a semi-tire casing on the highway, right? The difference between hitting and not hitting that stuff and being able to maneuver around it, if there's room in the lane next to you, is having healthy ride control, right? That helps keep all that steering and suspension in control. And so then we talk about shocks and struts. And as technical people, both as advisors and technicians, this term rolls off our tongue like butter, right? It's shocks and struts, shocks and struts. We say it all day. But your customer may not understand the difference. You have flip books available to you from us. If you open up the first tab, we actually have in there the difference between a shock and a strut. And what I like to point out to customers is, look, your spring is what holds up the corner of the vehicle, right? That's what's holding up the weight. Mr. Customer, we could technically steal the shock absorbers off your vehicle, and you wouldn't know it till you got ready to drive your vehicle away, and then it would bounce uncontrollably because we would have uncontrolled oscillation of the spring both up and down. We put the dampers back on it, healthy dampers, and they control that spring oscillation. So keep in mind, not only can the springs wear out, but healthy dampers are crucial to controlling the spring oscillation. So shock absorbers are less expensive than the other type of product that we have because right here we are combining both the spring and the absorber, the damper, if you will, into one unit. We call this a strut, or some people refer to it by its formal name, a McPherson strut. But this is a structural part of your vehicle. And if we were to take these off your vehicle and you came out in the parking lot, your vehicle would be on the ground and the tires would be flipped in an unusual position because these are a structural part of your suspension system. They have a very large diameter rod holding up that corner of the vehicle. Now there's about 5 or 6 major types of suspension out there. There's wishbone, there's double wishbone, But we're going to focus on just a couple of them here today that are kind of neat. So short long arm's been around a very long time. This is a very heavy suspension system, right? So you can see we've got a full frame. We have a large sway bar here. We have a spring, big heavy coil spring. We have an upper control arm. We just have a lot of weight on this vehicle that's added. Normally these vehicles are 300 to 600 pounds heavier than a vehicle of similar size that would have on McPherson strut. So what I want to point out here, I know we got words right here for reminders for you, but just please focus for a minute on what I'm telling you here about this application. The McPherson strut suspension is on many, many vehicles out there. It is probably the main thing that comes into your shop regardless of make or model, all right? We're even seeing this now on SUVs. There's all sorts of different ways to clamp them in or mount them in, but we're going to focus on a really common style here. And again, what I'm talking to you about here would be pretty applicable to almost any type of McPherson strut layout. So if you look on the back of a flip book, if you happen to have one of these, or you can get it off of our Monroe.com website, we have a 734 area code that rings into our technical resource center. And the number one volume call that they probably get is this: hey, we just put on a pair of your quick struts, or hey, we just put on a pair of bare struts, and we're getting noise, right? We're getting noise from the strut towers or the upper bearing plates, especially when we're going around corners. We're hearing a popping, a grinding, a snapping, a pinging, a clock spring noise. Show of hands, have you ever had this happen to you? You bet. Almost every one of you raised your hand. I'm going to tell you right now where probably that happened or why that happened. It's not going to be the case with every situation, but it's a pretty good thing to look out for. So if I'm the technician and I'm getting ready to change this unit out here, as I got the wheel off and I get ready to disassemble this thing and take it out, I would undo the ABS lead out of the clip, undo the bolt out of the brake hose, undo my stabilizer link connection, pull my 2 pinch bolts. I would reach up, grab onto the coil spring with my left hand, come over with my right hand or vice versa. And what I'm going to do is use my little 3/8 impact. I'm going to go zit, zit, zit. And I'm going to pull the 3 nuts off of the top. And now my strut's going to come out. Technicians, how did I do? Perfect. All right, good. So the strut's out. Now we rip open our quick strut box, and we pass the strut assembly up into the tower, right? We got it properly aligned down here with the clevis and the knuckle, and we push the studs up through the holes at the top, and we start our 3 nuts. Now, as technicians, we always think assembly in reverse order, right? And this is where a lot of technicians go wrong. They will actually install the 3 nuts with the zip gun or impact wrench, right? And you'll hear them go, brr, 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 and they'll tighten those 3 nuts back up. And now we have a strut that is mounted very rigid, okay? And so if this strut is very rigid, in order to get these 2 pinch bolts in down here, you will see people rocking back and forth on this strut. And they'll use pry bars and everything else on the lower control arm, the knuckle, trying to get these 2 bolts in, and they will get them in. But what they don't realize they did is as they were bending back and forth, they were actually damaging this bearing plate because it's clamped in tight up top. There's actually a white plastic ring in here. On most applications, that's a common design that we've got, as well as our competitors. And as you're bending back and forth, you're actually damaging either that ring or the channel that it rides in. And now you put the vehicle back together, you align it, you take it for a test drive, and it ends up making noise. And the problem is that instead of the strut moving perfectly smooth inside this bearing plate as you twist and go around the corner, we get a hang up of the bearing plate, and we get an indexing of the spring, which kind of creates a popping or snapping noise as the spring winds up and releases going through corners. The way we avoid this is by assembling the strut into the tower the same way they do at all the OE production facilities, and that is by tightening the top last. So what we want to do is back to step 1. When we pass the strut up into the tower, we start the 3 nuts, just 3 or 4 threads on each stud. And as we tighten those with just our finger, just a few threads, we end up with about a 1/2 inch of stud that has not been tightened yet. And so this strut will actually slop up and down nice and smooth. The bottom will swing all around where we need it to get our knuckle aligned, get our 2 pinch bolts in, put our stabilizer link connection back together, bolt back in the brake hose, ABS lead back in the clip, put our wheel on, tighten our wheel, and then what we want to do is go do the other side of the vehicle. Once all 4 wheels are on the vehicle, we want to set the weight of the vehicle down. The studs on the struts will finish pushing up through the strut tower. We tighten it to spec, and no more bearing plate noises, right? And so we want to make sure we're installing each and every strut that way by tightening the top last. So show of hands, how many of you know at least one technician in your shop who's been doing it wrong? I thought so. So almost everybody. So this is not a thing just to this area of the country. It's common across the country. Doesn't matter who the service provider is. A lot of technicians have been doing this incorrectly. Now you know the proper way to do it. So let's move on. Talking about a couple different design differences, every shock and strut manufacturer around the globe has to make two different designs. There's monotube and there's twin tube. Monotube is a single tube. You can see it here. They're long, they're skinny. They have kind of a squared off bottom on them. That's so this floating piston can come all the way down the bottom if it needs to. There's a pocket of gas separated from this area of oil right here by a floating piston that moves up and down. It has an O-ring fit right here. You can see the action in the visual on the left. That gas in the bottom on a monotube is typically somewhere between 150 and almost 300 psi. So there's a large charge of gas pressure in there. And this chamber up here filled with oil, this is where all of our damping takes place. And our piston would have our valving in it. And I'm going to show you that here in just a minute. All right. Now, monotubes are only on about 10 or 15% of the population out there of vehicles coming into your shop. Largely found on pickups, especially 4x4s, and some kind of European style sport touring vehicles. If you think of like maybe a BMW, or Mercedes, Audi, that type of vehicle that does sport touring. They're a little more responsive. They're a little stiffer, for lack of a better term. But again, don't worry about what you're going to put on the vehicle. You want to follow our cataloging, because if we pull a monotube off of a vehicle, we're putting a monotube back on. All right. And so the next version we've got is twin tube. All right. And what we've got with twin tube here, you can see the action on the left of some oil flowing through this base valve in the bottom. What they're showing is right here. And as the piston goes back up, some reverse flow happens. So this is twin tube. We've got a pressure tube inside of a reserve tube, and we've got oil flowing through our base valve, just a small amount of oil. And so we actually have an oil level that varies up and down kind of in this range right here on the outer reserve tube. I kind of think as the reserve tube is like the overflow jug on a cooling system. It is basically capturing extra oil and allowing that extra oil to go back into the pressure tube when needed due to pressure differentials within inside the pressure tube. Okay. The main thing to understand here is we do not have a floating piston, and so what we've got is a pocket of gas that should be residing out here in the reserve tube all the way around this thing, and it stays out here, and we want this pressure tube to be fully filled 100% with oil, and then we'll have again an oil level out here directly in contact with the gas. All right, so this is twin tube. This is about probably 85 to 90% of the population coming into your shop. And again, this is for shocks and struts. So we have shocks and struts that are monotube. We have shocks and struts that are twin tube, but primarily twin tube is the most common that we see out there. Notice they're a little shorter and squattier, and they have kind of a funny bumped outside out here. That's to allow the oil to flow to the outside. All right. So why did we walk you through all this? Again, follow your cataloging, put on what we recommend. But we're going to talk about valving. All right. So with valving, we've got over 10,000 different possible valving combinations. So what we're talking about is with all the different arrangements we can do of these different discs and what we call bleeds, right? This is the ones with serrated edges here. We got different thicknesses. We have some that are wider, some that are narrower, and they deflect differently, right, under different properties. So this is how we can create all the different part numbers. I always think of like a Cadillac CTS. We have several different part numbers for that vehicle on the front, especially because of the different tire and wheel packages that are out there and engine combinations, right? So we can't just have one unit cover them all. But when you look at the competition, especially low-cost countries, so this is all that stuff coming from overseas that's low cost that you may be seeing in your market, I would advise you, if you get underquoted by anybody out there, if you're quoting Monroe product, ask them what brand that other service competitor is putting on there. Chances are it's a low-cost country. If low-cost country, talk to your customer about, hey, the Monroe product is premium product. The premium product is limited lifetime warranty, and they have the correct valving so that it behaves properly on your vehicle, whereas the competition kind of takes this soft, medium, firm approach to their valving combinations. All right. And so back to what we talked about with twin tubes, there's an issue. So monotubes, the gas stays separate from the oil by that floating piston. But when we talk about on the left here, you can see when we set units on the shelf, what happens with twin tubes is that gas wants to rise to the highest point in the unit. And in this case, as it does that and it populates that top part of the reserve tube, some of that gas is going to start bubbling in through the base valve, right? Or even on its way to the upper part of the chamber. And what we end up with is a gas bubble inside the pressure tube. Now, this eventually is going to work out of there as the vehicle gets driven. But the worst thing you can have happen is your customer leaves your shop after buying tires or ride control from you, right? And they got the ride control put on with tires. they spend a lot of money with you, maybe $2,000 or more, and they leave and they hit their first pothole and they hear a loud clunk noise. Well, the clunk noise would be from this piston right here hitting the top of the chamber, and there's a gas bubble up there. And the way we get that gas bubble out of there is by what we call priming. So if you watch on the right here, and I would protect your hand or use a wood block or something, but we want to put the bottom of the unit in the downward position. I usually set them right on the bench if it's a shock or a bear strut. And then what we want to do is about 4 cycles of this rod going down. We'll push it down all the way, and we'll let it extend all the way. And as we're doing that, we're actually pushing gas ahead of the piston and pushing it out to that reserve tube. All right, this is called priming. You want to do this on bear struts and on shocks, okay? Now, some people will ask, how do I prime a quick strut? Well, one of the easiest ways is just a very thorough test drive, right? Where you've got some good stops and you hit some good bumps and maybe even a mild pothole or two, but we want to cycle those units, right? But way that I figured out over the years is, if I put them on the front of the vehicle, I like to, before I even take it to the alignment rack or as I'm moving it over to the alignment rack, right outside the shop, just at 1 mile an hour moving forward, I will slap the brake pedal and make that vehicle nosedive. And then as the vehicle comes up, I'll hit the brake pedal again and kind of get a few oscillations in there, and you'll be surprised how much gas you can move just by doing that. If I put them on the rear of the vehicle, I'll do the same thing backing up, just creeping back at like 1 mile an hour, hit the brake pedal really hard, make those units press as they bounce up in the air, then hit the pedal again and kind of get that oscillation going. And then again, a good test drive after you're done with the alignment. All right. Any questions on priming? Okay, good. And so show of hands, how many of you have never heard of priming, or if you're a technician who used to do it, you've kind of stopped doing it? Okay, almost every hand in the room. There we go. So that's why we cover it. This should be done on all twin tube units that are bear struts and shocks. All right. All right. So as technicians, we don't always follow the instructions that are on a vehicle or on parts that we put on vehicles, but we just want to point out we've got a few numbers that are have no gas in them at all, so don't be alarmed if they don't extend at all. And then we've got at least 56 part numbers or more that are low gas pressure. All right. And so what we're talking about here is sometimes you take the retainer strap off the units and they do not fully extend, right? And you think, oh, they're defective, or you're kind of pulling the rod to help them along. Well, that's because there's less than 10 psi of gas pressure in there. The one thing I didn't mention is on twin tubes, I told you on monotubes that the gas pressure is about 150 to 300 psi. On twin tubes, it's about 150 on the top end, and it can be as low as 4 or 5 psi. And we'll talk about in just a second here why we put that gas in there, okay? But when you get low gas pressure, they're not going to fully extend, or they will extend real slow. Don't be alarmed by that. There's no reason to warranty the units. We just want to make sure that the technicians are aware they may not behave normally like a regular pressurized unit. All right. So the one thing I wanted to mention is with the low gas units, just keep in mind that you can look that up online as well, and it will tell you if you don't notice the tag, or if you want to advise the technician beforehand. You can see online we will indicate that they're low gas units on our Monroe.com website. All right. So let's go into ride control service in 4 steps. Okay. Now we're getting actually into the recommendation of replacement to the customer. How do we come about that? And so let's walk through this. So the first thing is, this is a lot of verbiage right here from MAP. So MAP is the Motorist Insurance Program designed to protect the consumer so that you don't get parts being replaced on a vehicle that are actually not bad or defective or need replacement, right? So this is designed to protect the consumer. The document that you have in front of you that's laminated is MAP approved, all right? And so looking at the tail end of their paragraph here, or their sentence, which is quite extensive, you're saying they're talking about doing an interview with the customer or the vehicle owner, a thorough ride control component inspection, and a test drive of the vehicle, right? And we want to start doing this, as you can see on the right here, at 50,000 miles is our logo, and they also indicate it in their verbiage here, right? So at 50,000 miles, we want to start that inspection process. So let's summarize this as steps 1 through 3, right? For the MAP guidelines, we want to interview the customer, we want to do a road test, we want to do a physical evaluation. Now, I just want to point out one thing. We've added step 4, which is make recommendations. So this is something that you folks do every day, right? You make recommendations. So this 4-step process, if you think of it, if one of your good customers came in on a Monday morning and you asked them how you could help them, they said, hey, my vehicle's making a noise. And you ask them, well, what is the noise and when does it do it? Well, it does it when it's a squealing noise, and it does it when I hit the brakes. Okay, does the noise go away? Yep, when I let up on the brake pedal and take off from the stop. All right, well, we're going to have our technician take it for a test drive, right? And then they're going to pull it back in the shop, and they're going to put it on the hoist here. We're going to pull the wheels. We're going to check it out, and then I'll come to you with what we found. Sound fair? Yep. So the technician takes it for a drive. They hear the light squealing noise when they hit the brake pedal coming from the front brakes, and they let up on the brake pedal. It goes away. They pull it in the shop, and lo and behold, they find that the front pads are down to the wear indicators. And so as a recommendation, you end up quoting them pads and front rotors. You do this every day. I want to point out one thing. When it comes to ride control, it is the same process, right? We interview, we road test, we physically evaluate, we make recommendations. Now, I know sometimes it may not follow perfectly this pattern, right? The key thing is, just like putting an engine together, you got a 4-cylinder engine. When you got 4 pistons to put in, it doesn't matter if you put in step 3 or piston 3 ahead of piston 1. It does not matter. The key thing is that you get all 4 pistons in there correctly and that all 4 of them are in. So it doesn't matter if you do the road test first and then you physically evaluate, you find something and you go back and talk to the customer. The key thing is that we're starting that conversation with the customer. That is cool. It can happen at any point in the process, and usually you'll end up making the recommendation obviously last, but this thing just needs to have some flow and make sure we're covering this, okay? So let's go through maybe kind of how this flow may work in your shop, all right? So using your guide, we're going to follow along with that front, and then we'll flip to the back on the scorecard as needed. So the first thing is, we've got 4 questions here that we developed with MAP that are going to ask the customer about how is their vehicle controlling, right? Do they need to slow down in corners? Have they had to replace parts? How does it handle when it's windy out? So you can see those 4 questions listed. If they answer yes to any of those questions, again, this can be at the vehicles in the shop. It can be at the front end when they're coming in for an oil change. But I would encourage you to use this backside on paper copy right along with your regular repair order when you get vehicles in that have, likely maybe 80,000 miles or more on them, right? That's just a verbal recommendation I've got. You might want to start it at 50 because we're supposed to start the inspection process at 50,000. But as far as this backside and scoring it, definitely if it's got 80,000 miles or more, you should have this thing out and working it, because there's a good chance that you could end up recommending replacement to the customer of their ride control, all right? So yeses are ones, nos are zeros. Now, these questions are a bit dry, and you may get a lot of no's or I don't knows. There is one question I like to ask customers when they come in. Let's say Mrs. Jones is coming in for an oil change on her Chevy Malibu, and it's got 120,000 miles on it. I would definitely start this backside, this scorecard, right on paper copy. And even though she's only coming in for an oil change, right when she comes in for oil change, I'm writing her up. I'm going to ask her these questions, and she's going to answer, yes, no, or I don't know to these. And that's fine. Just go ahead and score it. But I like to ask this question of people that come in and they're carrying stuff in their hands or on their shoulder, right? So a lot of guys are carrying maybe a backpack for work or a small bag or whatever with a laptop in it, or ladies still carry purses, or students might be carrying a backpack, or people have just an iPad in their hand or one of these electronic book readers, right? I like to ask people, when you drive by yourself, where do you set your stuff? What do most people answer? That's right, the passenger seat. And then I like to ask them, hey, have you ever hit the brakes so hard that stuff has gone on the floor? And what do they answer? That's right, all the time, right? This happens to them all the time. And what I like to point out to them, and I'll actually just use my arm for this, using my hand as the front of the vehicle and my elbow as the rear of the vehicle. I'll say, look, Mr. Smith or Mrs. Jones, when your vehicle had a lot less miles on it, like maybe less than 20,000 miles, that didn't happen as often, because what happens is the nose of your vehicle would come down a little bit, the back end of your vehicle would come up a little bit, but because of the natural recline of the seating area, that stuff would stay on the seat most of the time and would only come off there if you hit them really, really hard, right? But for most stops, it would stay on the seat. However, as your vehicle wears out, just like our body wears out, that nose is going down more, that back end is coming up more, and now we're starting to throw that stuff on the floor more often than it should. We're never going to totally eliminate that, but today we're going to do a test drive right out here in the parking lot, and we're going to inspect your vehicle while we're doing the oil change, and we're going to look for the health of your steering and suspension, and especially your shocks and struts, and we'll get back to you with what we found, okay? So you can have a seat in our waiting area. Now, let's fast forward, all right? We're going to do the test drive, we're going to do the inspection, and sure enough, at 120,000 miles, we are going to recommend to Mrs. Jones that she put front struts on her vehicle. What's her answer going to be when she came in for a $50 oil change and we're quoting her, $800 or $700, whatever it is, for front struts? Her answer is going to be no, right? That's okay. What we've done by explaining to her about her purse coming off the seat, or to Mr. Smith about his iPad coming off the seat, right, and those conditions are coming off. What happens over the next 2 weeks when that stuff goes on the floor several times, right? What's the first thing they're thinking of when they pick that stuff up off the floor? That's right, the shocks and struts. We have done what I called planting the seed. We did not pressure sell the customer. We did not scare the customer. We did not make them feel uncomfortable. We just pointed out, hey, this is happening more often than it really should. And guess who's going to be coming back in, hopefully weeks or months later, or maybe even just days later, to get the stuff put on, right? It's just a no pressure sell. It kind of lets them know and come to the realization, hey, I need this stuff. All right. So let's move on to the next slide. So the next step is a road test. Now, I used to live in New York City area, and you do not like to road test out there because the traffic is absolutely crazy. And so what we want to do is what I call a parking lot checklist, right? And so this can be done right in the parking lot, and you only need to go 8 to 10 miles an hour. I've done this many times with technicians and service managers just to show them how to do it. So the first thing we're going to do is an acceleration squat, right? We are going to, from a stop, make sure we got a clear path out in the parking lot or in the area right next to the shop, or the stub street next to the shop. And from a complete stop, we're going to punch the gas pedal. And immediately we're going to be going 8 to 10 miles an hour. But what we want to notice is when we punch that gas pedal, the accelerator, what does the rear of the vehicle do? We should feel ourselves, rock back in the seat a little bit. Even if we're in a smaller vehicle with lower horsepower, we should feel ourselves, rock back a little bit. But I always say, if you feel your seat drop, the back of the vehicle is probably compressing too far, right? So what we want to do is note that. And then immediately right now we're on the brakes, right? So we punch the gas and we're at 8 to 10 miles an hour. In a very short distance, we punch the brake pedal. And as we punch the brake pedal, what we're looking for is nosedive. And every vehicle is going to nosedive, right? That is fine. But what we want to pay attention to is, does it come up nice and level like this vehicle here that we're seeing in the video? Or do we get those extra, as I call them, head bounces or spring oscillations, right? If we see that extra upward motion back to downward, that is worn out front, either struts or shocks on the vehicle, right? Worn out ride control. So we want to make a note of that, okay? And the next thing we want to do is, I'll usually back right up and do this in the same area. Put your hand at 12 o'clock on the steering wheel and just oscillate your hand back or swerve your hand back and forth between 10 and 2 on the steering wheel. Again, at 8 or 9 miles an hour, very slow. And the vehicle should really feel tight, like it's carving, like this vehicle is here. But if you feel that real top heavy body sway, which you're going to if you've got a vehicle with mileage on it, we want to note that on the scorecard as well. And so then the last couple things I like to check for is if there's some rough road surface or pavement surface in the parking lot, just run the drive wheels across it and see if you can get them to bark a little bit or slip a little bit. You can kind of feel that. And then also, as I'm coming in the shop, I like to listen for unusual noises. The way I do that is I put the front windows down in the vehicle. I leave the rest of the windows up in the vehicle. And what that does is kind of turn the inside of the cabin into like a stereo receiver, right? And so as I'm pulling slowly into the bay, I like to crank the steering wheel all the way off to the right, all the way back off to the left, and then back to center again very quickly as I'm moving forward, and kind of ignore the squeaking of the tires on the floor and listen for those popping, pinging, snapping, squeaking, kind of grinding noises from the strut towers. That will tell us about the condition of our bearing plates and strut tower area. All right. Now, this should make sense. So what we're going to do is we're going to document that in section 2. So this is typically the technician, could be the service writer, but there's 6 points possible here. You can see yeses are 1s, nos are 0s, and we got 6 points possible in section 2. By the way, this test drive, if you do it right in the parking lot or in the street adjacent to your shop, it takes about 2, maybe 2.5 minutes, and you are done with the test drive and back in the bay. All right. And now we're back in the bay. We're going to do our inspection. All right. And so what are we looking for? That's right, fluid leaking. That's the number one thing that people look for. And let's talk about that one real quick before we cover these other items. I just want to point out that there's a lot of misunderstanding around what is a leak and what is a weep or a seep, right? As kind of a layman's terms here. But what we're talking about is on this unit right here, on every shock and strut, we used to make the seal so tight on these units. So back in the day when I was real young, I changed a lot of shocks for leakers, right? Because they would be bone dry and then all of a sudden they would just come gushing oil. And the reason that happened is that seal fit right there was so tight that it didn't leak any oil. So you tell me, what happens to a rubber lip seal that does not get any oil or grease on the lip area? That's right, it dries out and it cracks. And when it cracks, it leaks, right? So what we started doing a number of years ago was we loosened the fit of that seal to this rod area right here. And what we actually want to see out of these is about 1 drop of oil per 7 days that the vehicle's being driven, right? So over that stretch period of time, we want to see about 1 drop of oil weep past that seal and come out of the unit. What that does for us is, number one, it keeps the seal healthy, right? It keeps that lip area moist and softened. And number two is it keeps a little bit of oil on our rod so we don't get rust on our rod. And then on this unit here, you can see this dust and dirt and debris at the top of the rod. It's actually floating that stuff up out of the seal area so it doesn't chew up the seal. It's floating it up the rod and kind of up to this area that hopefully doesn't get touched too often. So if you'll notice on this unit right here, it looks like coffee grounds at the top. It is perfectly normal to have a couple inches of kind of coffee grounds or moist or dry dust and dirt at the top of the unit. But what is a leaking unit is if this area looks wet and oily or shiny with oil, that would be considered a leaking unit. You'd want to recommend replacement. If there's oil running down the side of the unit, that is a leaker in which you'd want to recommend replacement. Or if this dusty, dirty area right here or moist, dirty area is starting to creep down past the top couple inches and working its way down the shock or the strut, we want to recommend replacement for leaking. Now, the one thing that would supersede this recommendation would be if there's any technical service bulletins or OE conditions from the dealer on what is a leaker, what not a leaker, because there are some vehicles that have issues. You want to follow that first, but this is just a good rule of thumb from the manufacturer as an industry understanding of it is normal to have some normal weepage that's going to build up around this top. Does that clarify that for everybody? All right, good. So we want to look at, see if we've got any bushings that are damaged or missing, or do we have pitting on the rod or any rod condition where it's not smooth, right, could be scored. We talked earlier a lot about wearing out front brakes, so look for excessive brake wear, and we talked a lot about tires, right? The one thing we didn't talk about, and I'll touch on very quickly, is jounce bumpers. So with jounce bumpers, this is what they look like new, and this is what they look like when they're pretty well done, right? And so per map guidelines, if it's deteriorated to this point, or worse, if it's altogether missing because it's crumbled and fallen out of there, we want to recommend replacement of that strut to the customer. So we put this jounce bumper up underneath the dust boot of every strut assembly. And what it is basically people call it a bump stop, right? We call it a jounce bumper, but it is like a bump stop, and it just keeps the unit from compressing too far. If twin tube units, struts were to compress too far, the piston will actually come down and smack the top of the base valve and damage. All right, so this is what we want to look for. All right, so let's talk about this. You got a vehicle in the shop. It's got worn out shocks and or struts on it. What are the components can wear out prematurely if we do not have healthy shocks and struts? That's right, ball joints. What else? Tie rod, yeah, exactly. Control arm bushings, exactly. So there's a whole bunch of stuff that we want to check on the vehicle to see if it's worn out, right? Even motor mounts, as the weight of the motor shakes up and down, right? So you can see we've got idler arms, ball joints, even CD axles, right? Control arm bushings. We talked a lot about brakes. We've already covered jounce bumpers and bearing plates. But we want to look at all this stuff and make a proper recommendation to the customer if some of this stuff is worn out due to the shocks and struts being worn out and causing extra cycles on these parts, okay? Don't forget the oil wears out in these things. So just like engine oil wears out, transmission oil wears out, axle oils wear out, so does shock and strut oil. And the only way to change the oil in a shock and strut is to change the shock and strut on passenger cars and light trucks, right? So just remind your customer that, hey, even though there's not anything physically outside the unit that we can see that's bad, during the test drive, we noticed these units did not behave correctly, right? They're really worn out. I want to show you with a test drive, show them with the test drive. So this oil, when it wears out, instead of it being around maybe a 15 weight viscosity healthy hydraulic oil, after it's got 50,000 miles on it, it's basically like a 1 weight or 0 weight, almost like water, and it's black, it's oxidized, it's not doing its job anymore, right? And we've also got worn out units or components on the inside of the unit here. So again, for shocks and struts, that's a good way to get a conversation with the customers about the oil wearing out. So we want to document the final section here, section 3, and I'll get to section 4 in just a second. So here's how I like to work this sheet. I like to add up sections 1, which has got 4 points possible, section 2, which has got 6 points possible, and in section 3, we document how the suspension stops damaged, etc. Or do the tires have unusual wear? Points possible here. So you got a possible 12 points, right? So if you add up sections 1, 2, and 3, you can put that total score for the S column right here. And let's just finish up with this sheet right now. If you look at the little guide below this, it says if the score is 4 or less, like 0 to 4, the customer does not need to replace anything on the vehicle, right? It's actually in pretty good shape. That's a great thing to share with the customer. positive thing to share with the customer. Most customers kind of bristle when they hear that. They know that their vehicle got an A or an A minus on the test for the day, right? Okay, but if that score is 5 or higher, we want to start a conversation with the customer about ride control or replacing that worn out ball joint or whatever we found, right? We want to start that conversation and start recommending replacement of the needed components to that customer. I will tell you from personal experience, if the score is a 9 or a 10 or 11 or 12, get the customer in the vehicle, take them out for a test drive, right? And show them what you found. You will make a believer out of them when they're sitting in the passenger seat and you're driving, okay? Now let's talk about section 4. Section 4 does not get added into our points total. You'll notice it's in red, and when you print it off in black and white, this is going to come out gray shade, which is fine. But if the technician finds any of the 6 things listed here, so for example, tractor strut is binding or seized or leaking, and you can see there's 6 things listed, and they flag any of these, per map guidelines, we want to recommend replacement of those units, right, as a pair, right? So we put everything on in pairs. And so we put on a pair of front struts or a pair of rear shocks, whatever it is. But what I like to do with this section, and this is my favorite section from an advisor or technician standpoint, is if we find anything in section 4, I am putting a pair of safety glasses on the customer, and I don't care if they have on a 3-piece suit with a tie or a dress and heels. I want to bring them out and show them what we found in the vehicle, because most customers, even though they have not worked on their own vehicle before, if you walk them out and show them, say, the driver's side front that's healthy and you really don't see anything wrong with it, and you walk around the passenger side where they've got a leaking front strut, if you just give them a few seconds, a lot of people will say, what's that stuff running down? Or if you point out to them, say, see this right here? That's hydraulic fluid leaking out of your units. Then you go ahead and start that conversation about, this is why I brought you out here, right? We're concerned that we don't know how much oil has been flowing out of this unit. It could be incredibly low. It didn't do well during the test drive. Therefore, today we're recommending replacement of these. Does that make sense how to use section 4? Okay, perfect. Any questions on the overall back side? So you got sections 1 through 3, you add up into section, to the worksheet total. We're good there? Okay, good. And then section 4, anything there you recommend replacement. Excellent. All right, so just finishing up with this thing, if you flip it back over to the front side, when you get in front of the customer, if they ever ask you, hey, why should I put this expensive stuff on my vehicle? What's the point of this, right? Because I think it's fine. Look, right in the gray area at the top, it improves control and handling. It reduces premature tire wear. It's going to basically extend the life of your tires from where it would currently be if we keep these worn out units on there. And it's going to shorten your stopping distance on most vehicles, right? Under certain conditions, it's going to give us a shorter stopping distance. If we replace those worn out units, it'll make your braking system perform better than it currently is. All right, so these are 3 great benefits to point out to the customer. And again, here's where I pointed out the scale on the back side. If you flip back over that, your points total, right? Any questions on that? All right, great. I'll probably cover this back at the toolbox, but I just want you to know right here in the bottom middle, there is feel the difference. This is a 90-day or 1,000-mile guarantee that we have, that if a customer puts on 4 corners and they do not like them, if they come back to you within 90 days or 1,000 miles of having them installed, and they don't like what they are feeling or experiencing with it, call this 800 number and they will assist you with that. All right, so I just want to point out that's on the back of your laminated guide. And so now let's make sure we're on the same page, right? As service writers and technicians, we got to have our story straight so that if we take the customer out to the shop or they go to another shop, that we've delivered the right message to them, that they've got a proper recommendation. So please have a discussion between the service writer and the technician. Make sure you two are talking before you ever get in front of the customer with your explanation of what's going on with the vehicle. And don't forget, this has been around for a lot of years, but our safety triangle, if you don't have your laminated sheet with you in front of the customer and you're getting ready to have that conversation out in the waiting area after you've done your test drive and your inspection, that's a fine time to approach them about replacing ride control. Just remember, steering, stopping, and stability, right? 3 great benefits of replacing ride control is that we get tighter steering, shorter stopping distances, more stable in those uneven or windy conditions, right? And of course, we know the replacement benefits of improved control, tire wear, and stopping distance, right? So let's keep moving on. So any final questions on how to use this thing, right? There's our 4-step process. We want to have a conversation, a test drive, a physical inspection, and make sure we're recommending replacement when needed on the vehicle. We never want to sell the customer something they don't need. That even goes outside the realm of shocks and struts. But any questions on how to do this 4-step process? All right, great. And just remember, as I said, this is like putting 4 pistons in an engine during an overhaul. I don't care what order you put these things in. Just make sure you have all 4 happen, right? That we're doing a good look at these things, inspecting them, doing a quick test drive in the parking lot or in the side street, and then starting the conversation with the customer, can be done at the beginning or the middle, it doesn't matter. And then the main thing is recommend them, right? And we'll talk about some recommendation practices here. Any questions in the backside? Excellent. Everybody's good with that. Show of hands. How many of you think this might be helpful with some customers that you're having coming in with higher mileage vehicles with actually recommending replacement to them? Excellent. Now you've got that tool available to you. Again, I'd work off paper copy and not try to write on the laminated copy because it'll smudge on you. But I think you're going to find this to be very beneficial. All right. So now let's shift gears a little bit. We have a lot of great product, and so we don't want to make this a sales pitch to you on our product. I think you're very aware of all these 3 brands that we've got listed there. We've got Monroe, we've got Moog, we've got Wagner. But I just want to very quickly move through what we've got available to you for product, right? So with Monroe, we've had a lot of innovations, and when we say innovations, I kind of look at this as clarifications, right? If you ever looked up in your screen for your system, and I'm not sure what system you guys use here, but when you look in that parts lookup, it can be overwhelming sometimes because we got OE Spectrum, we got Reflex, we got Magnum, we got Rancho, we got all this stuff available to you, conversion kit, right? So let's kind of run through this product line real quick. So OE Spectrum, this is our flagship product. This is about 70% of our sales. And the reason it's such a high level of our sales is this OE Spectrum base unit right here is typically what will get used for most of our quick assembly, right? So we'll put the new spring on top and new bearing plate and all new fasteners, all that stuff, a new dust boot, everything top to bottom new. So OE Spectrum is our flagship product. Again, it's about 70% of our sales. So for passenger cars, I don't care what badge is on the hood of this thing. Could be domestic, could be import. I would put on either OE Spectrum and or Quick Strut, right? Now, if you have mid-size SUVs like GMC Acadias, Ford Explorers, those types of vehicles on down to those smaller, the CUVs, I would recommend OE Spectrum and or Quick Strut, right? It's a great go-to. If they have full-size trucks or full-size SUVs and they do not use it, all right? So in other words, let's face it, I'm from a small town. I have people I know in town that the only thing they haul in the back of their pickup is a case of beer on Friday night to take home, right? So if that's what they're putting in the back of their half-ton Chevy truck, they don't need anything more than OE Spectrum, right? So for those trucks and SUVs that are not carrying loads, it's just people's daily driver, I would go OE Spectrum on that, all right? Again, or Quick Strut, if it's applicable. But if they are hauling things with their pickup, I would step up into Reflex. So with Reflex, we've got some technology here that's a little different than OE Spectrum. And so with Reflex, this is that next level up. This is great for people that are occasionally hauling things with their vehicles. So if you think of people pulling a boat trailer or a camper, or they're hauling firewood on the weekend, or gravel for their driveway, or it's an SUV and they're a scout leader and they've got a gaggle of scouts in the back on the weekend, right? And all that extra gear and stuff. Reflex is a great way to go. This reacts a little bit better to those loads when needed, and it's great for those trucks and SUVs that have that higher center of gravity or are a little bit top heavy, all right? I recommend, this is my go-to recommendation typically on a pickup or SUV out there. Just people seem to like them. All right. And this is what I've got in my pickup, by the way, and I love these things. In fact, I have a I Heart Reflex tattoo. All right. So Gas Magnum. With Gas Magnum, show of hands, how many of you are servicing any sort of a small business or maybe even larger fleet account where I call these the white pickup, white van people, right? Okay. So a lot of hands went up in the air. Do they ever overload them? You bet, right? First thing they do when they get it home from the dealer where they bought it is they pull it into their shop and they swap over all the stuff out of their old vehicle that they've got there and they put it in and it's instantly overloaded. So Gas Magnum does a really great job of this. This is a really beefy, larger diameter twin tube that we've got. So again, if this is offered for a vehicle and it's a white pickup, white van person, small business owner that's got a lot of weight in there, Gas Magnum's a great route to go. So don't forget about Quick Struts, right? So these are great from top to bottom. Everything is new. And again, the key thing here that's the backbone of the system is the spring. All right, so we're going to talk about these a little bit more and some of the technology here in just a bit. So just looking at kind of the 3 categories we've got our base struts. We'll continue to carry that coverage. Again, my encouragement to you is if you're going to put on base struts, please, please, please replace the spring, right? Why would you swap over a 10-year-old, 140,000-mile spring onto a brand new base strut and expect it to perform correctly? It's not going to, right? If you're going to do that, you might as well put a bearing plate on it. Oh, you should probably put a new dust boot on there. Oh, and probably a jounce bumper. So guess what? If you're going to go through all that and do it the correct way, why not just put on a Quick Strut, right? We got the proper coverage, and then it's limited lifetime warranty on this thing. And this is a great way to go, right? It's the correct spring for the vehicle, the correct valving, right? Now, some people will say, hey, I'd like to put struts on my vehicle, but I can't afford the quick strut, right? It's an older Buick or whatever. Do you have something less expensive? The answer is yes. We have Roadmatic. So this replaced if some people are looking for or familiar with the older Economatic, which was that retina laser blue paint on there. We now have the chassis black Roadmatic available. It has a 3-year warranty on it. Folks, these are great units. This is great for that kind of older vehicle. If the customer does not want to spend the money on a quick strut, it's still got the 3-year warranty. That might be all the longer the vehicle is going to last. Who knows? But these are good units, and they're doing very, very well for us out in the market. All right, so that's the coverage we've got. So just a quick recap. OE Spectrum for those light duty applications. Okay, so again, I don't care what nameplates on the passenger car, could be foreign or domestic, and then light trucks, SUVs that aren't hauling things. Reflex if they're occasionally hauling things. These are great for that. And then Gas Magnum for those vehicles that are commercial vehicles, right? White truck, white van, people that are overloaded. And then we've got Quick Strut out there available. So just think about Quick Struts for those applications as well. All right. Additional opportunities. We already talked about conversion kits at the beginning, but the one thing I want to talk about is Rancho. So with Rancho, we've got a full product line here. Again, follow your cataloging. We'll recommend what to put on a vehicle, but we've got the 5000 series twin tube, 7000 series is a long skinny monotube. 9000 series, you will notice in the bottom right here, it's got a red knob. This is an adjustable knob with 9 different settings. And so I'll give you a good example for this. My brother, with his F-250, pulls a fifth wheel. And he doesn't like how soft the suspension is in the rear with the fifth wheel on it from the factory. So put a pair of these on here for him. And he likes this because as you index that knob into setting number 8 or 9, it makes this unit much stiffer, right? So it handles those loads better. But then it's way too stiff to drive up and down the road on normal driving. So he reaches underneath it, takes him 5 seconds aside. He backs that knob off to like setting number 3, I think is where he likes to run. And these are great. They're an adjustable unit. So these are available for the, especially the rear, sometimes the front, on a lot of pickups and SUVs, okay, and vans as well. Now, we took that same technology and we rolled that into this product right here on the right, which is called Quick Lift. This is one of the hottest selling things that we've got out on the market. So what this is for all your newer, and I think it's kind of like 2016 model year and newer, somewhere in that range of GM, Ford, Dodge, and Toyota pickups and SUVs. And what this is it's technically a strut, right? But the upper mount here doesn't rotate as a bearing plate. It's just a rigid mount. But what we're talking about here is this is basically a strut. So if you take these off the front of one of those newer trucks and set it down, you're going to have the vehicle down the front of the ground and probably some damage. So make sure these are always installed on the vehicle before you set on the ground. But what we've got is the 9-way adjustable knob, first of all. So this is an adjustable unit from a damping perspective, right? But what these are is extended units. We call it Quick Lift because it levels the front end of the pickup out with the rear. When you drive by the parking lot of any of those manufacturers I just mentioned, and you look at their row of pickups, most of those pickups will be nose down in the front, unless they've had some sort of modification to them. And so a lot of people are in the habit of putting in the spacers up here to do that. I would encourage you not to put in spacers, even though we do offer them through Rancho. What this does is we keep the same distance between the top of the mount and what I call the bucket right here. We keep that distance the same as OE, so we get that OE ride. But we've extended the tube length and the rod length to actually level the front of the pickup with the back. This is not a universal fit unit. It's specific to each vehicle platform. So for instance, the pair of part numbers we have for the GM, I believe, raised the front end about 1.5 inches to level it with the rear. With the Ford, it's about 2.5 inches, and the Dodge is somewhere in between. Now, there are 3 reasons that come to mind that I think you'd want to put quick lifts on a customer's vehicle. Number one is some people just don't like that nose down look and they want it to set level, right? So I would not put these on somebody's vehicle who's going to haul a lot of weight in the back. Otherwise, the front end's going to set higher than the rear, and they're not going to like that as well. But if they want it to just set level with no load in it, this is a great way to go. Another way to go, and it's probably one of our most popular applications across the country, is accommodating larger wheels and tires in the front end, right? So once you get that front end up in the air, now you can put on bigger size tires all the way around. And the third one is for people that are in those northern climates where we have snow. I have found this to be a very good application for snow plows. So folks who go out and buy snow plows for their small business, and they have a 1/2 ton, 3/4 ton truck with the plow in the front, this is great to put these on there. It levels that truck before they put the plow on, and now it's not so nose down in the front with all that extra weight on it. And they can actually adjust the knob up stiffer for when the plow's on. And then the spring, a lot of those folks will switch over to landscaping, and they can back that knob off to a setting number 3 or 4. All right. Any questions on Rancho? All right, great. So don't forget what you've got available to you here. Max here, these are the ones that have the nylon air tubes running to them. So these are still available for the rear of a lot of vehicles out there. We got the load adjusting, and I covered that earlier for the pickups and vans that are hauling loads in the rear. And so we got strut made as well. All right, let's continue on. So why Monroe? Again, a lot of our OE technology gets rolled into our Monroe brand, right? So we've got that multiple valving that we do, or all the different valving combinations. We're using the proper materials. I'll hit on a few key points here very quickly. All right. So around the wheel, all right. Again, don't forget we've got Monroe. We're going to talk about Wagner and Moog here in just a minute, but just keep in mind we got around wheel coverage. So again, when you peek in that wheel well, we've got it all, right? So let's talk a little bit about the Moog stuff. All right. So with Moog, great product line here. And so Moog chassis parts been around a long time. I put a lot of this stuff on over the years. If you look, we got great coverage, right? And this has evolved over time too, because you used to have to always put ball joints in the control arms and stuff. So now we've got these loaded assemblies, which this is great. It reduces installation time, gives you a robust unit right out of the box, right? We're using a lot of specialized materials. So where some of the low-cost competition might use rubber, we'll use urethane, and we've just got all sorts of great materials here that we do. And we've got the unitized bearings, and we do some special stuff like a tough sheathing here on the casing on the wiring. So just a lot of great stuff. We'll run through this here pretty quickly. So first thing is engineering, right? It's all based in engineering. We're trying to exceed, not only meet the OE performance, but exceed it, right? So when you grab onto that Moog aftermarket product in your hands, we are probably enhancing and improving upon some of the OE design to make it even better, right? So we want to have this stuff really perform for you out in the field, and I hope you're experiencing that as well. And you think about even on like ball joints, we call it our problem solver. So what we do is we've got this pressed in plate. It kind of works like a Welch plug basically, and it basically holds all of the materials or all the components in place. It keeps it tight so that we don't get that extra slop or play in the component. And again, we're using premium materials in here for all of the soft components, all the hard components, right? And again, we'll try to do greasable as well wherever possible. All right. So that's what I want to talk about here is I remember certain applications where they did not have greasable components, and what they had was non-greasable, and so we get contaminants of water in there. One of the purposes of lubrication is not only to lubricate, but to flush out all that contamination. So whenever possible, we make sure that it's available. All right. So then on the problem solver control arms, again, these are loaded assemblies, right? So we got the CK and R series as well. And again, these are loaded assemblies right out of the box. Again, premium materials. So just keep in mind, you don't have to press that ball joint in and out. You can actually just buy a loaded assembly, right, and get the whole unit replaced. There's a good chance that you've got wear anyways on these bushings. And so if you're going to replace a ball joint, you've got wear on bushings, why not just put in a whole unit, right? Great way to go, quick turnaround in the shop. And so when you look at things like these sway bar links, right, these are great. We've done some improvements here. So some of them can be lubricated. You can see here we've got the advanced materials here. We're not just using rubber, we're using urethane. So we'll take a little peek here. This is one of the things that used to frustrate me is right here when you used one that was OE design, right? Try to get that nut on there. You've got to somehow squeeze this washer down enough to get one thread started so you can draw this nut up. Well, what we do is we got this Moog barrel nut design where this is actually threaded inside this barrel for easy starting of the nut, right? And we use premium urethane bushings instead of rubber. So again, this is just great material, a great product. I would encourage you to use this whenever possible. Knuckles, right? I remember pressing in a lot of bearings and arbor presses, and you get rust you got to clean up and all that. Now you got a complete knuckle assembly, a loaded assembly that's available. Comes with the bearing, comes with the knuckle. We're not going to have any of that wallowing out or wearing out of where the ball joints would go in. Everything's going to be good here for the brake application. This is just a great all-around unit, right? You got all the surfaces new again, and you got a unitized bearing already pressed in. Great way to go, right? Saves a lot of time. It's going to help you pump a lot more jobs through the shop quicker. And again, we've got this abrasion-resistant cord. We're using a lip seal that's premium, right, to keep that debris out of the bearing. These are great units, and the coated wheel studs, right, help with corrosion. Again, there's just a lot of great features on these unitized bearings, these hub assemblies. I would encourage you to stick with a product line. You don't want to put something cheap on a customer's vehicle. On any of the stuff I've talked about today, whether it be shocks and struts or bearings or spring suspension, right? We're going to talk about braking in just a minute. I find that whenever you try to cut costs and go cheap, you're asking for trouble, right? You're asking for a comeback, and a comeback can be costly not only from the repair, but from the fact that you lose a good customer. All right. And then universal joints, right? So we've got a whole series of these available, great coverage out there. And when applicable, most of these are going to be greasable, right? So just, again, even our seal materials on these, we're using premium there, nice heavy duty needle bearings. Again, I'd encourage you to use the Moog universal joints driveline product line. All right, so that was a quick snap at Moog. I know we're moving through this pretty quickly. We're kind of on the home stretch here. We want to just cover a few more things because then we're going to finish up with Walker exhaust and emissions when we're done here. But let's talk a little bit about Wagner, right? So there's a lot of different braking product lines out there. I've used most of them myself and a lot of that competitive material, but I'll tell you what, Wagner is a go-to for me over the years. It's a great line, right? So not only do we have the friction material like the pads and the shoes, but we've got the rotors with the correct finish and a good coating on there, proper venting, right? So a lot of low-cost country product will not have proper venting. We ensure that it does, and we do thorough testing on that. We've got the full line of brake hardware kits. We've got all the hydraulics, right? The wheel cylinders, the master cylinders, and hey, we've even got the fluid to go into that system, right? And this is premium stuff as well. So Wagner, I'm proud to say that this is just one product line that I stand behind that I think is very robust, not only from a coverage standpoint, but from a reliability standpoint, and just the engineering that goes into this line is just phenomenal. All right. When you look at our pad lineup, right, we've got a lot of different products here. And I don't like to think of this as different levels like good, better, best. I like to think of it as what is it going on for an application. So you've got the OEX, right? So the one up here on the left, which is really designed for, pickups, SUVs, even the CUVs, right? These are engineered correctly for those applications, right? For that kind of pickup SUV line. And then we've got the TQ, right? The thermoquiet. So this is a kind of a go-to product for us as well for passenger car. And then we got Quick Stop, right? And this Quick Stop right here is going to give it the vehicle an almost like new braking performance. So this is just a great premium product. And then we've got the SD, right? So this is for those kind of, I think, like fleet applications, right? If somebody's putting on a lot of mileage, we want to think about maybe going to this SD. These are a very robust product line that work great. And then don't forget about Ferodo. We've got this here. It's actually made in Europe. Most of it's made in Europe, and it's for those European applications. All right. So let's keep moving here. So one thing that there's a trend of right now, and this has been growing, is to go towards ceramic. So ceramic does a few things for us, right? It does good heat management, but it also creates a lot less dust. So people have these beautiful wheels, and if they use semi-metallic, or heavy semi-metallic content pads, they will get a lot of heavy black brake dust on there. Ceramic dust, it doesn't stick like the semi-metallic does, and it's a lot less dust. So this is a thing where when you go to pick out a pad, if you pick it out based on the applications being used for, we will have the correct formulation in here with a blend of whatever materials we need to be correct for that application. All right, so just feel good about when you go get ready to grab any one of these boxes. Again, follow your application guide for this, and we'll recommend what should be on the vehicle, and it's going to have the correct formulation. All right, great. And so one thing we're going to be is conscious about the environment. So some years ago, they figured out that copper was getting out into our environment and affecting especially like fish life and wildlife, stuff like that. So getting into our water streams. So you've got, look for the leaf, right? But what I will tell you right now is that with the Wagner product line, we are right on track with where we need to be for copper content, right? So we're phasing that out, we're getting it out of there, and we're going to have it down to, and we're following all the requirements for federal out there, for EPA, and we're going to hit this mark, okay? So just feel good about when you're putting this on that it's meeting all the requirements it has to for the EPA, all right? Premium pairing, so we got this great line of friction. Don't forget that we've got the rotors as well, right? With the proper finish on there, so that we get that quick brake feel right away. You don't want to use your friction material to seat in the rotor, right? We should have the correct rotor finish, and we do right out of the box. And it's also got the correct ventilation. That's key to the duration and life of these units, is that we've got the correct venting. So, we don't use just one standard venting pattern. It's specific to each platform that we've got, right, for optimum cooling. And so then when we look at what we want to have here, right, when we start looking at lightweight rotors from competitors, what we'll see is, uneven braking surfaces, right? So maybe their casting process is off, or their machining process is off, or they're just real too thin from the factory or where they're manufacturing it. We have the correct thickness. They're going to be even. We're going to have the correct ventilation. So again, the rotor line is very robust, very well designed. And you can see right here some of the venting patterns for the vane designs that we have. And again, it's going to be vehicle specific or application specific, and it's going to be the correct ventilation working in conjunction with the wheel package that's on there, and to properly cool the braking system. All right. A couple technical tips here. Just want to cover these very quickly. So look for any unusual wear patterns or debris, right? So there's a lot of different things that can happen here. We got tapered pads, right? We want to start looking at, how's the caliper mounted? Is there bent mounting pins on there? Uneven wears usually due to a lack of lubrication, or we got something hanging up within the caliper to a bracket area, right, or the bracket itself. Ashing from overheating. Metal residues usually from somebody turned rotors and did not properly finish the rotors, and then did not wash them properly afterwards with detergent and water. And so we got little flecks of metal actually embedding into the pad. We can have damage on the back plate, not allowing the back plate to secure properly. Pad cracking due to overheating, right? Surface contamination. Gang, for my technicians out there, if you get contamination on the pads, you want to wash it off with detergent and water, not soap and water, but actual translucent or clear detergent and water in the sink. I would encourage you to not spray brake clean on here, which a lot of people tend to do. Brake clean can actually start to soften the resin. So again, I encourage people to pop these out and wash them in the sink with some detergent and water. Dry them with a clean paper towel. Or shop towel that's clean, but not the cloth ones, because those can have residue in them as well. So use paper and get those things cleaned up, right? And obviously wear out down to the indicator. So these are just a few things to look out for, all right? And so pad wear indicators, right? So we've got, we got paper, we could have brackets or hardware that's bent. So we want to look for that, right? And I'm moving through these pretty quickly just because we got a lot of content to cover here. But again, any unusual wear, and a lot of this information is available out on our Wagner website, okay? And you can also talk to your local TPS from Federal Mogul, all right? So feeding these things in, this is one of the biggest mistakes I've seen technicians make. They will spend all that time, right, hours doing drums, rotors, and getting it on and lubricating everything properly, and everything's clean and everything's ready to go, and then they'll go out and they won't do a proper seating in of the friction material. So what we really recommend is about 20 complete stops from 30 miles an hour. You don't need to go any faster than that, and then you got to let them properly cool off in between, right? So it's not like you want to just go out and stop, go. You want to get a little driving distance in between your stops to properly cool off the rotor as well, right? And so kind of the rule of thumb that I have is just be nice to the brake material, right? If you think about a brand new engine, right? If you did an engine rebuild, we're not going to go out and hammer the thing down to the floor and see if it blows up or not, right? We want to do a proper break-in. We want to let it warm up. So we want to let our brakes warm up a little bit. We want to let that material start to seat in. But just be nice to them. Again, 20 complete stops from around 30 miles an hour all the way down to 0 with a little bit of drive time in between of 30 seconds. Let that stuff cool down and then do another stop, right? So yeah, it's going to take you a good 10, 12 minutes to do to seat these things in, but you're doing a proper break-in, and that way you won't have a comeback for noise or other issues. All right. Any questions on that? All right. Good. Thanks. All right. So again, rotor finish is critical, right? We want to have that good finish on there, and so all the Wagner rotors coming out of the box are going to have it. If you look at issues out there, people put rough of a surface or a phonographic finish, or it's so rough it'll actually scrape off material off the pads. We want to have that correct finish, and every Wagner rotor is going to have that from our factory, right? So that we get that immediate seating of the brake pad and correct smoothness of the rotor. All right. So let's take a look real quick at the toolbox that we've got. So we're kind of getting back into ride control. We're just going to finish this up for our around the wheel section, and then we'll get into some exhaust emission stuff. So with the toolbox, just wrapping up, keep in mind we've got consumer promotion coming up. So March 1st to 31st, so for the full month of March, we've got up to $100 Visa prepaid gift card back to the customer for buying any either Tenneco, right, premium product, or Rancho product, right? So this is premium product. If they're buying it, they're going to get some money back, and it has all the details on the back side of this thing of what they're going to get back. Also, for our technicians out there, we have they can earn $40 back for every pair of premium quick struts that get installed. That's going to run for 2 months. So from March 1st through April 30th, right, if they're part of the Expert Plus program. So you want to look at the details on the back side of this flyer when it comes out and make sure you're tracking correctly. Then you got to have your stuff postmarked by May 31st to get that. All right. We've got for our service managers out there, we're running a promotion of the top 10 service managers that following their Monroe sales goal, if they're over their Monroe sales goal, that will be tracked by corporate, you're going to get a $500 prepaid gift card, right? So the top 10. So for service managers out there, that's a pretty nice payout to ensure that you're hitting your goal. But obviously, we don't want to put ride control on a vehicle if it doesn't need it. So again, we only want to sell ride control to the customer, recommend replacement of the ride control to the customer when needed. All right. And this is one of my favorite right here. The lunch is on us, right? So lunch on us by Tenneco. We're going to have winners every 2 weeks. There'll be 2 winners, one for exhaust and one for shocks, right? And they each receive a $200 gift card, and that's a Subway gift card, and so you guys can have lunch on us, right? So there's details here, and again, that will be tracked by corporate, right, at the sales level. We got flip books available to you. Again, these are great for explaining the difference between shock and strut, if the oil wears out. There's all just sorts of great information in there. So I'd encourage you to have one of these behind the counter. I normally don't leave it out in the waiting area. I like to leave it behind the counter and kind of have it as one of the tools in my toolbox where I'm getting ready to have a conversation with the customer about recommending ride control replacement. All right. And so one of the last things in here, I already touched on Feel the Difference briefly. That's available on our website as well, more details on that. But be part of the Monroe community. We have an app that you can put on any of your smart devices like your iPads or your phones. There's tech bulletins out there for the technicians. Look up information for advisors. There's service grams. There's just all sorts of, there's the phone number for our technical resource center. There's just all sorts of good information out there. And again, our Monroe.com website is a great place of information as well. So any questions on all the around the wheel stuff that I covered, either ride control or Wagner or Moog? Is there anything at all that I can answer for you right now? All right, we've covered a lot of ground. So we're down to what I'm hoping is about the last 15 minutes here. I do want to take a chance to talk to you a little bit about Walker. So first off, show of hands, how many of you in here are currently performing exhaust repairs in your shop, at least catback or at some level? Wow, not a lot of hands. So for those of you that didn't raise your hands, raise your hand if you were not aware that you had this even available to you or the capability in your shop. Okay, so a lot of hands, right? So this is why we're bringing this up. With Walker, you have a direct fit opportunity, right? So with Pep Boys, you guys are stocking this at your warehouses. A lot of the stores have inventory, and so it's not just for the parts side of your business, it's also for your service side, right? So out in your shops, we'll talk a little bit about here the different things that we have available, but I do like it because it's direct fit. So the days of doing all this torching and welding and all that stuff today is largely bolt-in. So let's kind of work through what you have available to you. Full product line, right? You've got mufflers, several different versions here. We have cats available to you. I'll talk about that in just a minute. Resonators, pipe, flex pipes. If it's a manifold that incorporates a converter, so you would actually have a manifold on back system available to you, right? Hangers, gaskets, all that stuff, right? And all sorts of additional accessories. So just look in your system and see what's available. And again, Walker, we're the world's largest OE manufacturer. So not only do we produce stuff for you folks on the aftermarket side, the reason we have such good coverage and this direct fit line and it'll fit right in is we make a lot of the OE stuff as well. So this should be exciting and encouraging you to, especially for my technicians out there, to be on the lookout for this stuff when it's got pinholes or rot or anything or rust. Let's look for that, right? And or noises, right? If we got a muffler that's worn out, so good opportunity for you here. So looking from front to back in the vehicle, all the way from the manifold back here, we've got converters, we got intermediate pipe, muffler assembly, resonators. So it doesn't matter if it's pickup or passenger car, this light truck, we've got all this stuff available, right? So we'll talk about some of this product that's available, but the main thing I want you to remember is you need to stress to the customer that their exhaust having a leak in it is kind of a dangerous thing, because the sole purpose of exhaust, our main purpose is a safety issue, right? And we want to push the exhaust out the back of the vehicle so it does not get drawn up into the cabin area, right? And get in our air and have people breathing, toxic fumes or whatever in the exhaust. So we want to have a healthy exhaust system. We don't want to have any pinhole leaks or gasket leaks. So check this stuff over, make sure it's healthy and in good condition, right? It reduces sound level, it controls that as well, and helps us with our engine performance. And we'll talk about converters here in just a second. All right, so here's our converter. It's kind of I call it the magical part of the system, but it's really not. A lot of people misunderstand what a converter does. Some people think it's a filter where it filters out, bad stuff. and it's really not a filter, okay? A lot of people think it incinerates or burns. You hear people say, oh, it burns the stuff inside burns the unburned fuel inside the converter. That's an exothermic reaction, no different than in a combustion chamber of an engine. People like to think that the fuel burns. That's a layman's way of putting it, or a simple way of putting it, but it's actually an exothermic reaction creating heat. So what we've got inside our converter is a lot of bad stuff coming in, right? So we've got hydrocarbons, which is hydrogen atoms and carbon atoms hooked together in different combinations. There's some different forms of fuel out there, but we got unburned fuel that didn't get burned in the cylinder. We got carbon monoxide, which is formed from partially burned fuel. We got NOx, which is a nitrogen and any number of oxygen hooked onto it. All these are bad for us to let out in the environment, right? So what we do is inside this converter, we have catalyst in here, hence the name catalytic, right? We have platinum and palladium that are grabbing onto oxygen, to free oxygen atoms that are in there, both singles and doubles. They're grabbing onto it, and they're going to hang on to those and hand those off to this bad stuff to turn it over something that's acceptable that to go out in the environment, right? Like nitrogen, CO2, and water. So let's just walk through a couple of these real quick. If I take CO on the way by, when I go through my brick right here, if I hand it an oxygen, now I have CO2, which is carbon dioxide. Plants breathe CO2, we can now send that out the pipe, right? If we take hydrocarbon, right? If I take these C's right here and hand them O2s, it rips the C's away from the H's, and we send the CO2 out the pipe. And now I've got these H's in there, and they will pair up as H2s. Well, we don't want hydrogen going out the pipe, so guess what? We give it an oxygen, and now we have water, right? So that is why when you walk by a vehicle that is running healthy, and you feel the exhaust on it, it should feel warm, not hot. It should feel warm, and it should feel kind of moist or sticky on your hand. That's because we're developing some H2O, not only in the catalytic converter, but we actually technically will have some coming out of the combustion chamber as well. All right, so as you can see, there's these reactions going on. These are exothermic, they all create heat. We've got rhodium in here to split up NOx. So it actually divides nitrogen away from the oxygens on there. The oxygens get used for reactions. The nitrogens pair up into N2 and go on out the pipe, and we're breathing 78% nitrogen where you're sitting right now, right? So again, acceptable items going out the tailpipe. Then we monitor those are these O2 sensors right here. So really all that O2 sensors see are O2, right? That's why we call them an O2 sensor or an oxygen sensor. So that is how the PCM is using with a before and after O2 sensor to monitor how well is this catalytic converter working, all right? Now let's talk a little bit more about this system here. So you've got bolt-on, right? Direct fit, bolt-on converters and mufflers. You can see here we've got a converter incorporated right with the manifold. So this stuff is great, right? It bolts off, it bolts on. If you've got bolts that can't come out, you might need to get the saws all out or do some drilling or whatever, but we want to get these things out of here, right? And you don't have to cut or weld to put it back in because it's going to bolt up, right? So we don't see shops doing all the MIGging and TIGging and stuff anymore of welding. They are actually going to just bolt in, right? So we like this because there's no special tools. This is a good opportunity for you to grow your business in your Pep Boys bays and not have a big equipment expense, for welders and all that stuff. All right, so don't let it go down the road. So let's talk about what kills cats, right? As I say, converters don't die on their own, they get murdered, right? Is kind of the saying I have. So they don't fail on their own, something takes them out. So what happens is a converter that's running healthy, and I could have pointed this out on the earlier slide, but from the front of the converter to the back of the converter, if we look at this one here, if it's a healthy running system and everything's in control, we will see a 100-degree temperature increase from the front to the back. So if we shoot this front weld ring, and let's say we see 350 degrees or 400 degrees, then I should see 450 or 500 on the back. I should see a 100-degree increase across the converter, right? That means all these reactions are generating heat, and that's a properly functioning converter. However, if I see 350 degrees here and 350 degrees here, that means my converter is not currently doing any conversions, right? There's nothing going on inside the converter. The exhaust is just passing straight through. That does not mean my converter is bad. It just means that it has not lit. So we have to have 500 degrees approximately of temperature on the inside of the converter, somewhere between 400 and 500 degrees for it to light. And once it lights, all those catalysts become active. And now what we do is start creating this 100-degree temperature differential. So if it's the same temperature here as it is here, the catalytic converter is not lit, but it is not necessarily bad, right? So we got to do some diagnosis. We'll talk about that coming up here with our 5 checks. I want to see about a 100-degree temperature differential. That's universal across all makes and models and platforms of vehicle out there. that around 100 degrees is what we should have for a difference. So you can shoot that with an IR temp gun or an infrared cam and kind of tell what your temperature differential is. Now, if we see this kind of discoloration, that means that I probably saw 150 degrees or hotter temperature differential with the IR temp gun from here to here. So I shot, 300 here, and I saw 450 here. I shot 350 here, and I see 500 here. When we see about that 150 degree temperature differential or higher, they're actually melting the brick on the inside of the cat. That is not the fault of the cat. The cat is only reacting to what's being sent to it. We got to figure out why is this happening. And the number one cause of melted bricks or destroying converters with overheat is misfires, right? So when you have a cylinder that does not fully fire the air-fuel mixture, that charge of air and fuel comes down here. It reacts inside the catalytic converter, and we get what I call a runaway, right, where it actually overheats and melts the brick. And that starts to happen somewhere around 1200 to 1400 degrees inside the cat is typically what I understand happens, and we start to melt the brick. Now, if we catch it soon enough, I will say catalytic converters, cats can have multiple lives, but we got to check for restriction and flow, and we got to make sure that we got the proper temperature differential after we correct the problem, like the bad coil pack or the bad spark plug or whatever we found, right? Some other things to look out for. If the catalytic converter stops working and you put one of our cats on, and the customer comes back a few months later and it's not working again, you should have checked the first time for contamination, because if the vehicle is using oil or coolant, it will varnish over or coat the catalysts that are in here, and eventually enough of it gets coated that it can't react anymore, and the cat will unlight. So we have to think root cause, right? So here we got overheating, typically due to misfires. Here we've got coated substrate due to oil or coolant fouling, right? And this one here on the right, structural damage, is just a bad driver. So we got to figure out, what did the driver do? What did they run over? And talk to them about, hey, this is physical damage that happened when you ran it over the curb or whatever they did with it, right? So this is what we want to look at. So these are not warrantable conditions, but these, again, are the real common kind of failures that we see. All right, so hopefully that was helpful for you. So we talk about 5 checks. These are available on our walkerexhaust.com website. We call it the 5 checks. Check number 1, you want to look for PCM trouble codes, right? Is there anything else in the PCM system that's causing an issue? We also want to look for technical service bulletins, right? Is there anything out there that's common with that vehicle platform that's going on? And PCM reflashes. Now, you may or may not be able to do reflashes in your bays. If you can't, check with the local dealer for that brand of vehicle. See if there's a reflash available. A lot of issues are corrected by doing PCM reflashes, updating the software and the computer for, say, the fuel control or timing or whatever it is to correct these issues, right? So that we get a properly running vehicle. Another one that's probably most overlooked is exhaust system leaks. So I'm on check number 2. And I want to point out that if you've got an exhaust system leak, especially anywhere upstream of the converter, the O2 sensors actually calibrate by taking a sniff, if you will, of the outside air. And they're looking for 21% approximately oxygen, right? It's 20.946% oxygen and in normal environment. So what happens is when we have leaks outside the exhaust system, those can throw off the calibration of our O2 sensor. So think about it. If I have a manifold gasket leak, and as that exhaust goes by my O2 sensors, it could throw off the calibration of my O2 sensors. There's nothing wrong with the O2 sensors. There's nothing wrong with the PCM. The catalytic converter is not bad, but that whole system is getting messed up because of an exhaust leak. We fix the exhaust leaks, we fix the problem. All right, so it's not always some deep technical part like a catalytic converter or an O2 sensor or PCM or reflashing. It could be a simple exhaust system leak. That can also happen downstream of the converter. So that rear O2 sensor, if it's within 18 inches downstream of that, keep in mind your air swirls around underneath your vehicle. It could be throwing off the calibration of the O2 sensors. All right. So again, exhaust system leaks. That's why it's number 2. It's one of the most common overlooked things, right? Make sure the vehicle's in proper fuel control. So what we're talking about here is checking your fuel trims. But for those technicians that have done any drivability or emissions diagnostics, you know what I'm talking about. What we're talking about here is the control system within the PCM that's actually trimming fuel up or down, right? It's actually adding fuel or taking fuel away, depending on, do we have a small intake manifold leak, or do we have a leak somewhere past the mass airflow sensor? The PCM is going to dish in a little more fuel to comp for that, right? And we want to correct the problem, right? We want to fix that leak intake manifold leak, or we want to fix that exhaust leak, or whatever it is that's causing that thing to not be in proper fuel control. Check number 4 is contamination. I covered that already. Again, we're looking for coolant system leaks. commonly head gaskets or intake manifold leaks where we're drawing in coolant. Could be oil consumption with today's low tension rings. A lot of OEs are having issues. Again, with oil contamination, contaminated converter, we've got to correct that issue, right? Rather than just throwing cats on it left and right. And check number 5, make sure you got the right part. So we'll cover that a little bit here with the coating that's on the converters. All right. So step 1, underneath the hood on every vehicle, every modern day vehicle, I should say, there is an emissions tag, right? Some people call it the VEC. I just call it the emissions tag. There's an engine family number or an EFN. So all these tags are going to look different depending on the OE. However, they are required by law to all have the same information on there. They're just laid out a little bit different. What we're looking for is the group on here, right? We're looking for the engine family number, and we're looking for this code. And then when you go to look up a CAT for a vehicle, if it lists multiple codes or engine family numbers, you want to make sure you're getting the right CAT for that vehicle. One of the key things out there is there's what I call a federal emissions, which is for 47 states now, kind of emissions, right? And then for 3 states, California, New York, and now Maine has joined on. They are going to follow CARB or California emissions, right? Which is a much more stringent cleanup of the exhaust. Okay. So step 1, locate the tag, right? Step 2, find the engine family number. Step 3, make sure you're looking up the correct unit for the vehicle based on that information that you've captured. All right. And you can always call on our website on walkerexhaust.com. There is actually, so here's the website, walkerexhaust.com. You can call our tech line as well. They will help you look up the correct converter for the vehicle if you need to. All right. So just looking at product a little bit. So we talk about EPA and CARB and all that good stuff. There's actually codes on the converters, right? So there's an executive order number. If it's a CalCat, right? There's Walker part number on there. There's a date of manufacture, so we can document that as well. But we want to talk about making sure, like, look at these numbers, right? If you got a vehicle coming in with an issue, first thing I would check is, did they get the right CAT on it, right? They might even have it off of the wrong vehicle, under that same manufacturer or something. Just make sure it's the right one, okay? And then we want to talk about UltraCat. So this is our best seller, right? This covers most of the applications out there. You can see it's a 25,000 mile warranty on the emissions. It's 5-year 50 on the structural. But this is kind of our go-to, right? For most applications, this is mostly what you're going to be putting on unless you're in California, New York, or Maine. And so again, follow the coding and make sure you're getting the correct one looked up in our application system. Okay. The Walker UltraCat, I'll just mention quickly, we do have and I don't think I got a slide on, but we do have an EX, so they got a little extra loading in there. If you see an EX offer, you may want to put the EX on. All right, it's got a little extra loading of the catalyst in there. Okay. And so here, now we've got CARB, right? So with CARB, it's going to clean up a lot more of the emissions, right? So you can see California, New York, and Maine listed. And one thing I will tell you from personal experience is, technically after the warranty has expired, the 8-year 80 from the OEM has expired, you technically could put on a federal emissions CAT on a California emissions vehicle. I would not do that. We sometimes index or twist a little bit some of the flanges or some of the connections on the CARB or what we call our CalCat product, different from the federal. So sitting side by side, it looks identical or at least similar. And if you try to put on a little bit less expensive federal one, it will not fit correctly. This is my rule of thumb. If you have California emissions, right, CARB compliant emissions on the tag, put on a CARB compliant CalCat, right? That way you won't go wrong. And it's going to have the proper loading to keep the check engine light off. All right. Any questions on that? All right, good. So the right support, you can see if you go to our website, we've got a 734 area code listed. You can call that anytime that you want. We've actually got a direct CARB compliant hotline. So the person answering that phone is very good at CARB compliant questions. They are there from 8:30 to 5:30 Monday through Friday. These folks are sharp. They will help you out. If you go to the www.walkerexhaust.com website, there is a ton of information. You are going to like this, right? It is going to be helpful to you, and you are going to get a lot of information out there. There's tech bulletins, tech tips, all sorts of good information. All right. So who's excited about exhaust now? All right, great. So any questions on exhaust? All right, good. I would encourage you to not let this stuff go down the road. Do the jobs, get them in there, do what you can on them, and I think you're going to enjoy it, right? It's another nice piece of business for you, and another thing that you can do for your customer, because every time your customer goes down the road, they may go to a competitor, and then you may lose that customer, right? So let's keep it in house. Any questions on how to use this conversation guide? We've got the front 4-step process. Again, I don't care what order you do these in. Make sure all 4 get done, right? Make sure we knock all 4 pistons into the engine correctly and clamp them down, right? So we want to talk about front side, make sure we're doing all the steps there, do it thoroughly, and then the back side, the scorecard, right? Make sure that is available on paper copies in your shop. So any questions on any of the round the wheel stuff? Anything on Wagner, anything on Moog chassis? All right, perfect. Well, that concludes our presentation. I want to thank you, and I believe I ended right at about the 2-hour mark. So you can see for my TPSs out there, this can be done. And so at this point, usually what I will do with the class is kind of hang around, answer any questions. You have some people stay behind. I want to thank you so much for taking the time to listen to this. Again, my name is Greg Neuenfeld. It was great meeting all of the TPSs in Southfield. I guess it's almost been 2 weeks ago now. But it was great. Feel free to reach out to me. I know I was copied on a couple of emails from Brett, so you got my email address there. So it's pneuenfeld@tenneco.com at this point. Feel free to reach out to me. And if you've got any questions at all, if I can help you with this, I'm happy to help you. Okay? So at this time, I'm going to end the recording, and I appreciate your time. Thank you.